of measurement and calculations. Medication orders, it is very important that you as the medical assistant or nurse can read the medication order that the physician has written. With electronic medical records, this has gotten somewhat better as physicians are typing out medication orders versus handwriting them. However, there are digital ink over forms where the physicians still are able to handwrite them. If you can't read an order, it is important that you clarify the orders with the physician prior to administration. You must have all 6 parts of a medication order, so the date and time of the order, the patient's name, the medication name, the dosage and amount of the medication, the way that you are going to administer it, and the directions for use. So when are you going to administer and how frequently are you going to administer? So this is kind of a fun slide that summarizes the methods that we can give a medication, so topical, oral, IV, parenteral, or the forms, so solutions, transdermal, solids, and inhalation. But really what I want you to remember out of this slide is the 6 rights to medications. So the right medication, the right documentation, the right route, the right time, the right client, and the right dosage. This is very important. In many of your classes and even in the clinics, you will hear the 6 rights to medication. So you'll want to pay attention to those. Some sources will have 5 rights to medications and some will have 7 or 8. So it really is dependent, but for this class, we are going to use the 6 rights to medications. Systems of measurement. So the apothecary system is almost obsolete. The conversion that you will want to remember will be 1 grain equals 65 milligrams for your calculations. The metric system consists of 3 different units. So grams equal weight, liters is for volume, and meters is for distance. And then we also have the household system. Sometimes we use this for cough syrups and such. It is the least accurate out of all the dosing and calculations. However, it is still used for, like I said, cough medicines and those sorts of medications. So the 7 major prefixes for the metric system, we have micro, milliliter, centi, deci, deca, hecto, and kilos. You will want to pay particular attention. I would say the ones that we use the most are micro, milli, and kilo. Metric system examples, so 1 microgram, we have listed here. 1 milligram, we have listed, and then how 1 gram, and then 1 kilogram. This is how the metric system is laid out when we have 1 of each. The ones in red are the ones that we use the most in the clinic. Household measurements. It's the least accurate. The most common measurements among the clinic setting are 60 drops equals 1 teaspoon, 3 teaspoons equals 1 tablespoon, 2 tablespoons equals 1 ounce, 8 ounces equals 1 cup, 2 cups equals a pint, 2 pints equals 1 quart, and then 4 quarts equals a gallon. So you want to pay attention to those different household measurement conversions. Common medical conversions, you will want to memorize this slide. You will need this for your medication calculations and then when you go out to the clinic. So 1 gram equals 1,000 milligrams. 1 milligram equals 1,000 micrograms. 1 kilogram equals 1,000 grams. 1 kilogram equals 2.2 pounds. 1 teaspoon equals 5 milliliters. 1 tablespoon equals 15 milliliters. 1 ounce equals 30 milliliters. 2.5 centimeters roughly equals 1 inch. 1,000 milliliters equals 1 liter. 1,000 cc's equals 1 liter. cc's are not commonly used anymore. We usually are using the milliliters. However, every once in a while you will see the cc. Cubic centimeters is what cc stands for. Other conversions. So, temperature conversions. We have Fahrenheit equals Celsius times 1.8 plus 32. So for example, if we have 22 degrees Celsius, you will put the 22 where the C was in the equation, and then times out what is in parentheses first, and then add the 32, which will give you 71.6 degrees Fahrenheit. For Celsius, we take Fahrenheit minus 32, and then we divide it by 1.8. So if we had 71 degrees Fahrenheit, we would put the 71 where the F is in the equation here. And we would do what is in parentheses first, so 71 minus 32. And then we would divide that by 1.8, which equals 21.6 degrees Celsius. Understanding decimals. All the numbers on the left of the decimal are whole numbers. Anything on the right of the decimal point are fractions. Okay? The position of the number to the left or right of the decimal is the place value. So when I say round to the 10th, I only want one number after that decimal point. When I say round to the 100th, you want two places here after the decimal point. If I say I want a whole number, I don't want anything after the decimal point. It needs to be all before the decimal point, okay? The value of each place left of the decimal is 10 times that of the place to the right. The value of each place right of the decimal point is 1/10 of the value of the place to its left. So what I really want you to remember is when I say you need to round to the 10th, there's only going to be one number after the decimal point. When I say round to the 100th, you need two numbers after the decimal point. And if I say round to the 1000th, you should have three numbers after the decimal point. This is very important in medication calculations, because oftentimes we are rounding these medication numbers. So I will show you some examples in a couple slides later, okay? So reading decimals. So 1/10 here again. So here, if I say round this number to the nearest 10th, it would be 23.4, okay? If I say round it to the 100th, it would be 23.45, okay? And then if I say round to the 1000th, which we rarely do in medication calculations, but if I say round to the 1000th, it would be 23.456. So, medication math steps. Make sure all units are the same. So we're starting out with milligrams or micrograms. Make sure that they are all the same. So if you have one that is gram, you will need to convert that to milligrams, okay? Or vice versa. You can convert everything to grams. But usually it's easier to convert grams to milligrams than it is milligrams to grams. Or if you have something in an equation that is grains, you will want to convert that to milligrams first before calculating out the whole equation. So the equation we use in the medical assistant program, the nursing program does use a different type medication math steps. They use dimensional analysis. We use something a little bit simpler. We use dose divided by what you have on hand times the quantity. So the dose is what the physician, ordered. So D stands for what the physician ordered. On hand is what we have in the medication cabinet, what we have available, okay? And then the quantity usually is milliliters, cubic centimeters, sometimes, which you rarely see, but not all equations will have this quantity part. Some of it will just have the dose divided by what's on hand. Usually the quantity only comes in when there is milliliters listed in the equation, which equals the amount that should be given. Be sure to label all of your medication math problems with either milliliters, milligrams, grams, whatever you used as a basic unit. Rounding dosages. If the dosage is over 1.0, the dose should be rounded to the nearest tenth. So for example, if we had 1.32, after we did all of our calculations, it would be rounded to 1.3. If we had 1.38, we would round up to 1.4. So if it is 1.35 or higher, we are going to round up. If it is below 1.5, we are going to round down. Okay? If under 1.0, the dose should be rounded to the nearest hundredth. So if we have 0.374, this would be 0.37, okay? So we would go to the second place. If we have 0.375, we would round up to 0.38. So here again, 0.35 and higher gets rounded up. If it's 0.4 or lower, it gets rounded down. Round appropriately. So less than 1.0, round to the nearest hundredth. So example, if you have 0.75, we would round that to the nearest hundredth. Okay, this is rounding to the nearest hundredth here. If you have greater than or equal to 1.0, round to the nearest tenth. So 1.1 is a good example of how we would round to the nearest tenth. Label all your answers, so either milliliters, milligrams, micrograms, scored tablets, etc. That needs to be in your answer or it will be wrong. There is always a 0 before the decimal point. So notice how I have zeros in front of my decimal points. This is to ensure patient safety, so we don't misread the medication calculation or medication order. So a 0 is always before the decimal, but never after the decimal, okay? Because sometimes if you have 5.0, that can be misinterpreted as 50 instead of 5, okay? So it's very important to put zeros before the decimal, but never after the decimal. If you do not do this in your medication calculations, it will be marked wrong. So, for example, our order says amoxicillin 1 gram, and then on hand we have amoxicillin 500 milligrams per milliliter. So the first thing we need to do is convert our like units, okay? So these do not match here. So the easiest way would be to convert grams to milligrams. So 1 milligram equals 1,000 milligrams, okay? So then we would take that 1,000 milligrams and divide it by 500, which is what we have on hand, okay, which equals 2, and then we times it by our dose, which is that 1 milliliter, okay. These two milligrams will cancel each other out, so we will be left with only milliliters as our unit. So we end up 2 times 1 equals 2 milliliters, okay. If we did not have milliliters here, this would just be 1,000 divided by 500 milligrams equals 2. And it would be 2 milligrams because they're like units.